Hello, students. Welcome back. So, in this session, we're going to be covering hypothesis testing. We will try to understand the z test for mean through some examples. So, let's try to understand statistical hypothesis, what that is. It's a conjecture, it's a claim that you make about a population parameter. For example, your population parameter could be mean, it could be variance, it could be any statistics. Okay. Now, this conjecture, this claim that you make, it may or may not be true. Now you will have two hypotheses. You're going to have null hypothesis, you're going to have alternative hypothesis. Your null hypothesis is denoted by H0. So null hypothesis states that there is essentially no difference between your population parameter and the observed parameter. You did an experiment, and based on the experiment, you conclude that there is no difference between your population parameter and your observed parameter. On the other hand, in other words, nothing is happening here. Okay, that's what it's saying. Nothing is happening here. Status quo. Your alternative hypothesis, denoted by H1, okay, it states that essentially there is some difference. There is a difference between your population parameter and observed parameter. In other words, you did an experiment, and based on the experiment, this is what you determined, that there is some difference between your population parameter and observed parameter. In other words, something is happening. So let's try to understand this through a simple example. Imagine you are a school principal and you have a new method, you have a new teaching style in the school, and you want to test if this new teaching method does it improve the test score. So you're going to have two hypotheses, null and alternative. Your null hypothesis would be that the new teaching method, okay, it has no effect on your test scores. In other words, the student scores, they remain the same as before. Nothing happened. No significant change because of the introduction of this new teaching method. That's your null hypothesis. Your alternative hypothesis, H1 in this case, would be that your new teaching method, okay, it had some positive effect on your test scores. Your student test scores, it did actually went up. Something happened. There was a significant change. Side note, your null hypothesis is not always about comparing population mean and your observed mean. You can be comparing your proportions, you can be comparing variances, correlation, regression coefficient. You can be comparing any of these uh, uh, population parameters. So, hypothesis problem generally they fall under three categories: left tail test, right tail test, and two tail test. Let's try to understand left tail test. Imagine that a car battery manufacturer, okay, he claims that they have a new AA battery and that lasts for exactly 50 hours of continuous use on average. Okay, that's what the car battery manufacturer claims. The government wants to verify that. A consumer protection agency, they want to verify that. So what they do, they want to test. They want to test if the batteries actually last shorter than claimed. Maybe they're suspicious of that. They want to test maybe it lasts shorter than 50 hours. So the two hypotheses in this case would be your null and your alternative. Your null hypothesis would be that your average, your mean is 50 hours. The batteries last exactly as claimed. Okay, that will be your null hypothesis. Your alternative hypothesis in this case would be that your mean is less than 50 hours, that the batteries last shorter than claimed. That's your alternative hypothesis. Now, this would be called a left tailed because we are testing if the battery is significantly below, that's the keyword, below the claimed threshold. Another example, let's say you have a water treatment plant, okay, and they have a new filtration system, and it supposedly reduce your contaminant level to below 5 parts per million. The environmental engineers, they want to verify this claim. They want to verify that the filtration system, it performs better. In this case, you're going to have two hypotheses, your null and your alternate. Your null hypothesis will say that your mean is 5 parts per million. The mean contaminant level, okay, or the mean contaminant water level is exactly 5 parts per million. That's your null hypothesis. Your alternate hypothesis would be that your mean, okay, mean contaminant level actually is less than 5 parts per million. That's your alternative hypothesis. Now, again, this is a left tail test. Okay, this is a left tail because we're dealing with the contaminant level that is below the claimed threshold. So remember the word below. All right, below. Okay, now Let's look at the right tail test. So let's say you have an engineer. They develop some kind of new protective coating for the metals. And this protective coating, it actually increases the lifetime of your metal components used in automotive manufacturing. Now, if the mean lifetime of your component without the coating, we know this, the mean lifetime of the component without the coating is 36 months. We know this already. Then the engineer's hypothesis in this case would be null and alternative. Null hypothesis would be that the mean is 36 months, that the coating does not change the mean lifetime. Alternative hypothesis in this case would be mean is greater than 36 months, that the coating, when you apply the coating, it does increase your mean lifetime. That would be your alternative hypothesis. Now, this is a right tail test because we are specifically testing if after the application of coating, the lifetime exceeds, okay, significantly exceeds the minimum threshold. Another example, imagine that you jog every day, okay, that you jog every day and that you, on a day, in 1 hour, your average distance that you jog is 5 kilometers. So that's your average jogging distance in 1 hour. Now you get in a new diet plan, you get in a new jogging plan. Maybe you have a new pair of shoes, you're eating good food or something, whatever it is. So let's say after 2 weeks, okay, after 2 weeks of new jogging plan, you want to prove that your average jogging has improved, okay, it has gone up. So in this case, your null hypothesis would be that nothing changed. Your mean is still same, 5 kilometers per hour, 5 kilometers in an hour, in 1 hour. The new jogging plan did not change the average distance jogged. So that's your null hypothesis. Your alternative hypothesis, okay, is that your average, your mean actually is more than 5 kilometers. The new jogging plan that you have, it did increase the average distance jogged. Now, this is a right tail test. Why? Because we are specifically testing if employing the new plan, the average distance jogged significantly increased. Okay, we are testing that the average jogging distance is, does it increase or not or no. So now, two tail test. Let's take a look at this example. Let's say you have a medical researcher, or they're interested in finding out whether the new medication, okay, whether the new medication that they have just designed, okay, whether would it have any undesirable side effect. Now the researcher, they are particularly concerned about the pulse rate, okay, they want to know the pulse rate. So will the pulse rate go up, okay, these are the side effects, or it can decrease, or it can remain unchanged for a patient after he takes the medication. Now the researcher already knows from their past data that the mean pulse rate for the population under study is 82 beats per minute. They already know this data. So the hypothesis for this situation is this, that the null hypothesis states that the mean equal to 82. The mean will remain unchanged. The alternative hypothesis in this case, that the mean is not 82, that the mean will change. The mean could be either more than 82 or it could be less than 82 beats per minute. Now this is called two-tailed test, since the possible side effects of the medication could be to either raise it or lower the pulse rate. It can go both directions. Let's take a look at another example. Let's say you have a software drinking company. Okay, they have a bottling machine, and this bottling machine actually fills the bottle with exactly 500 milliliter of soda. Now, quality control manager, he suspects that maybe the machine might be malfunctioning. Maybe it's not working right. It could be either overfilling or it could be underfilling. So in this case, the hypothesis for him would be this right here, null and alternative. Your null hypothesis would be that your average, your mean, that the machine is not filling correctly, that your mean amount that is putting in the bottle is 500 milliliter. The machine is not filling correctly. Or alternative hypothesis could be that your average amount of liquid is putting inside the bottle, it is not equal to 500 milliliter. In other words, there is a change. There could be more or there could be less drinks going inside your bottle. So this test is called two-tailed test because the machine could be filling less or it could be filling more.